I started recording it. Okay, and then share screen. All right. Okay. Right. Okay, let's have a look at this one. Yeah. Oh, right, thank you, man. Okay, right. Let's try the question.
No, I thought you were out chocolate. Woo! That's fighting talk. What am I doing?
Okay.
Box is in the exam.
Sorry, there you go.
No, wait, so let me check.
Doesn't matter. Don't
Actually, there's only us. Yeah. Well, the board is like here.
Other things that makes much difference. Okay.
Actually, so we are in rotating now.
Doesn't matter. Okay. No, what does it do? I remember what. Okay. So according to Discovery Channel's National Geowild, sometimes they give you a whole lot of, like this question. There's a lot of waffle at the beginning. Wild hogs in North America are causing millions of dollars. Forget a highlighter out. Let's highlight what's important. Worth of damage every year. I would never put my pen back where it's supposed to be. My pen on your desk. There it is. Okay. Okay. Despite their trailer construction, they are surprisingly difficult to track down. They're sneaky, in other words. They can feed on almost anything from roots to rubbish and don't seem to be preyed on by the animals. Well, what animals are left? A sow has 3 litters per year, so we're going to need that. Each with an average size of 4 piglets. 60% are female. Survival rate is high at 80%, and the average hog lives for about 7 years in the wild. First question. Calculate the annual growth rate of wild hogs. In other words, our intrinsic growth rate correct to 3 different places. Okay, I want to change one question here. Question C. Instead of after 2 years, can you make it after 2 years? Is it boring? Let's do it after this question C. Please make that 5 after 5 years. Instead of 2 years. Right. So question A. Scare, can you hear me and see the screen?
Yes, sir.
Okay. Right. The growth rates are the biggest mistake people make with growth rate is they forget about the death rate. Okay. So growth rate is equal to birth rates minus death rates. Growth rate is just R. Once you send a message to the grade and tell them that your I don't know, my company wonder where the hell the pre-work for your test is on Teams. Math test. Okay.
You sit in the math chat.
Okay, so the birth rate is going to be percentage females, which is 60%. The survival rate of the piglets. So every year, how much does one female have? One female has 3 litters per year, and in that she has 12 piglets per year. Okay, and of those, 80% survive. So that is your birth rate. That ask you for your birth rate. That'll be your birth rate. Okay. Then your death rate. Okay. Death rate is what? How long did these guys live for? 7 minus 1 over 7. Pick that over in your calculator.
Yes, that's the section.
They said 3 decimal places, I think.
But generally, what is the for the section? That's
Generally, two.
okay. So
Okay, so that's for this generally. Okay, so we end up with 5.6 to get that. And what's that as a percentage? 516.7%. You don't write it as a percentage, but that's just to show you that it's going pretty ballistic, right? Yeah. What did you multiply from one population to the next, just out of interest? 6,617, right? So it's counting by a scale factor of about 6,6 per year. Okay. All right. So that's our percentage rate. Okay. So that's A, done. Okay. B, express the growth rate in whole population as a recursive formula. Okay, using an annual growth rate of 5. So this is what we often do. We ask you for this answer to 3 decimal digits. But in the next one, we say, this is how I usually set exams as well. I say use 5,6. Okay, so then you don't just write down 5,6 here and not knowing what you're doing, then I get all confused trying to figure out how you've actually got that. In the meantime, you just read it from the next question. Okay, right. So now we're going to use R is equal to 5,6. So try B. Oh. I don't think they give you more to do in minutes. Do you want to put it in? If you want for me to check you. Yeah.
next thing is mine.
A whole lot. Okay. Now they don't give you oxygen per minute. Okay, so P to the n plus 1 is equal to P to the n 1 plus R. So P to the n plus 1 is equal to P to the n 5,6 plus 1 is going to be. You might need it later. Okay, right. For now, it's no, you. Okay, so that's our formula. Right, then it says calculate the whole population of the 5 years. It's got currently 25 hogs on the farm, use an annual growth rate of 5.6 hogs per annum. Okay, so that's just calculator work. Don't do, okay, just, okay, right, so C then. So now we know that P0 is equal to 25, eh? Okay. Don't start D. Okay, so P0 is 25. So on your calculator, you're going to put 25 equals, and we're looking for what? P5, eh? I got 313,000. Am I right?
Yes, yeah, cool.
Okay. 313,083. Between 3 and 3,000. What are you supposed to say the whole crappy sentence? Okay, right. Now pause. Okay. We'll work out again. Okay. We found this ridiculous because no model is perfect. So in reality, probably not even that close to it. Okay. Right. Now I want you to go back, please, to your notes and to page. Yeah. Okay. So here, yes. Right. So if you've got a recursive formula, okay, let's have a look here. Okay. So sometimes, listen up, please, guys. Okay. We have, go back to page, what is that? Page 1, 2. Okay. Right at the bottom of that page, right? And you're given the thing about equilibrium. So this, if you have normal Malthusian growth, That's how your population grows, right? There's your Malthusian formula. But then sometimes they say to you, every year, put your post, or you want to color a certain number, or something's going to happen. Okay. So there's an extra bit over here, where you minus some amount X. So if this was a formula and they said every year we got what 50 hogs get shot, then your formula for this particular question would have been P to the N plus 1, what was our growth rate? 5,6, is equal to P to the N 6,6. And if we shot 50 pigs a year, it would be minus 50. That'll be your formula. Okay. This, as soon as you do that, this now cannot be written. You cannot use compound interest for that now. Okay, this is why we generally stick to recursive formula. Because you couldn't, there's no recursive formula for this. We know explicit formula. Okay, as soon as we start adding or subtracting, okay, a constant at the end, okay, we can no longer use compound interest formula, or we can't get an explicit formula for that. Okay. So now we have what's this thing? Okay. I'm going to show you now, in my opinion, the easier way of doing this, how equilibrium is explained. So now this farmer wants to kill a certain number of pigs, okay, in every generation, okay, and wants to know how many pigs or whatever they call hogs a year, right? So here's our thing. So if we wanted to keep the population at P0, okay, if we've got equilibrium, then from one year to the next, the population stays the same, right? So here's our formula. But if we want the population to stay the same, what happens is that if we want to keep it at P0, those two things stay the same. Do you agree with that? If one becomes P0, we're going to have equilibrium. Okay? And so the textbook always explains it like this, but okay, if you look here, go take this here and go solve for X. Look what happens. I want you to try and go solve for X in this over here. So what's going to happen? I'm going to move X to the left, right? And I'm going to get P0. I'm going to times that out, right? So P0 on plus P0 minus P0, right? So I end up with the amount that you've got to kill every single year is going to be P0 times R. Okay, that will keep the population, and it makes sense because this is how I think about it. That will keep the pop. Fine, we'll be back there on the screen when it comes back on. Sorry, load shedding people at home. Be back on now. Just how much you?
You can do it. I'm good.
Amazing. You got to do that. 10-second gap. It's like been waiting for this moment for this. It's like looking at the one of them gap. And I tell you, and the gap comes and right, it's okay. Okay, go back to you've got another minute. Go, tell it. Are you guys still in the meeting though? Zamasa?
Yes, sir.
Okay. The board will be back now. You can still see the board, we can't. Okay.
It's still there. Does it not look like that anyway?
All right. So guys, if you look here, let's think about this. In our formula, right? This thing over here, what was R? It was your growth rate. This is your R was 100. So if it was 100 things and 20% of growth rate, that would be 20% times 100, right? Basically, that's your increase, your natural increase per year, right? Okay, so you want to balance, you want to get rid of the increase. You want to balance with it. That's all you're doing. You with me? Okay, so you can go through all of this thing there, but essentially what you're doing is this is your increase. You want to keep the population in equilibrium, then how much you decrease it, okay, would be that, right? You with me? Okay, so if I had a population and I wanted to keep my population at 1,000, okay, then how much you'd, if it was at 1,000, then what you destroy would be 1,000 times R. That's what you get rid of. So that's how it would increase naturally. Does that make sense? Yeah.
So instead of one coming, then the rate, the intrinsic growth rate increases.
Good, I guess. If you ask me anything, I guess it's whether you can do it is a problem. I can't really answer that at the moment. Yeah, okay, but be careful now. Okay, so that's the first thing, right? Now, if I had a financial maths question, but said here in question B, the farmer decides to start exterminating the logs immediately on a weekly basis, right? So here's the first problem. Up to now, everything's been what? Yearly, right? If I had a finance question, right? And I started to deposit now every single week, what would have to change in a finance question if I tell you the interest rate was 15% per annum, but you're going to make weekly deposits of 200 Rand, an annuity? Well, you can't change the weekly deposits, right? But you have to change from an effective interest rate to a nominal interest rate. Okay, now, because at the moment, we were given an effective interest rate of, which is our growth rate. We're using R is equal to, did I say this question, what must carry on with? Okay, 5.6, right? So at the moment, our R is equal to 5.6. That is effectively per annum compounded annually. That's how these hogs are growing, like the interest rate of the bank. 5.6% per annum compounded annually, right? Same idea, right? But now we've got to change the time frame to weeks. So what I want now is per annum compounded weekly. And when those two stated period and the compounding period are different, this thing over here is now called the nominal interest rate. And if you look at it's not given in course, but it's given in AP, but it's given in a slightly different way. If you've got on your information sheet, on your information sheet, it says, you go to the finance and modeling, you're given this.
Yeah, because he was saying something. He didn't say anything bad, but.
So this is on your information sheet. Right, okay, right. Enough about this slide, anybody is. Okay, yeah. Delete. Okay, back to us. Okay. Right, okay. Anything else in the formula sheet? Okay. Boss. Similini. Okay. Right, so this is on your formula sheet. So this is your effective interest rate. Okay, this thing over here, this actually is your nominal interest rate. Okay, and K in this formula is the number of times per year. Okay, right. So now we need to go find out. Okay, we've got to first go find the nominal interest rate R to the end. Leave it as a ratio. Okay. Okay. What do we know? This is actually you given this formula like this in core. You have to remember this. 1 plus I effective is equal to 1 plus I nominal over M. Remember that? Okay, or 1 plus I, sometimes they're not effective and nominal. The our I effective is equal to 1 plus the nominal interest rate. Instead of using M, we use K to the K minus 1. So it's in a different form, right? But in this case, what do we know? The effective with the nominal. Okay, which was 5.6. Okay. So we've got 5.6 is equal to 1 plus. All right, this is R52 in the bracket, means I'll be an interest 50. It's per annum compounded weekly over 52 to the 52 minus 1. Right? I just wrote R to the 52. That's the notation I use. That we often use in a bracket. All that means is per annum compounded weekly. Okay. I'm going to interest 52. You don't have to write the 52 in there if you don't want to. If you're writing R nominal, that's also fine. Right. So now what you're going to do in your calculator, let's do this together. You're going to go 5,6. Remember, you're in a rush. 5,6, you can use solve. Okay. When you solve, you solve. You know, you solve. Okay. So you can use solve, it's perfectly fine. You have to show any working. Okay. You can, what are you using that calculator? Let's get a decent calculator.
So this one.
You did it to her.
No, I missed it to her.
Oh, sorry. Okay.
It's the best
So
one.
that's not what you're using for your strict line. Okay, good. Right. Okay, so if you go solve, and let's give your answer to quite a few decimal places. You're going to reduce to 3. I had 1,922. Okay. Yay. Okay. Did you solve?
Yeah.
Okay. So I get R is equal to 1,9 to 2. Okay, R to the 52. That's per annum compounded.
Yes. No.
Okay, so that's the interest rate I'm going to use per annum compounded weekly. Okay, as a percentage, it would be 19. I don't know. Okay. We haven't answered the question. What does the question? So that's how much, that's your rates of increase per week, right? Okay. So, but we've got to divide, hang on, be careful. In the formula, okay, this was a financial math question. And I said to you, the interest rate is 192.2% per annum compounded weekly. In our compound interest formula, what would I be? If I use, when I go A is equal to P1 plus I to the N. As an interest rate, I'd use that. Just per annum compounded weekly divided by 52. This is what you get in a year if interest was compounded weekly, right? Okay, you with me? Okay, you with me? That's in a year compounded weekly. So in every single week, you'd receive that divided by 52, right? So if I said to you now, if I gave the same formula, okay, for growth rates, but in terms of weeks, so the growth rate for this population in terms of years, what was the formula? We had P to the N plus 1 is equal to R, which was 5,6 times PN. That's when my time frame was years, right? My time frame is weeks, from 1 week to the next. What's it going to be? Well, I'm timesing by, okay, it would be 6,6, wasn't it? 6,6, 6,6 PN, right? Okay, that was 1 plus R, right? So it would be P to the N plus 1 is equal to 1 plus R times PN. But what would you use as R? It's per annum compounded weekly. That's in a year. So in a week, it will be 1 plus 1,922. No, because I'm not using compound, this is a recursive formula. I'm not using A is equal to P1 plus I to the N. I'm using P to the N plus 1 is 1 plus R times P to the N, the recursive formula, right? So the growth rate per week, just like a financial math question. Remember these questions when I said interest is 12%, 10% per annum compounded monthly. What do we call that kind of interest rate when it's quoted like that? When it's per annum, but it's compounded. Those two things are different. That's a nominal interest rate, right? You were doing financial maths now, and I said you invested R1 million. Okay, how much are you going to get after 10 years? What would you do? You'd go A is equal to P, whatever, R1 million times 1 plus. What would you use as your interest rate? You wouldn't just use 10%. What would you use? 10% over to the number of months, right? Same thing here. I changed it to a nominal interest rate. If it was per annum compounded weekly, it was 1,922, right? Okay. So now my formula is in terms of weeks. So if you're getting 1,922% per annum compounded weekly in 1 week, you want per week compounded weekly, you divide that by 52, just like you divide that by 12.
But would you not say to have a power limit for the?
No, that's the compound interest formula. I'm just talking about the interest rate.
Sure.
The recursive formula is that. Okay, if I was using a compound interest formula, yes, then I would do that. Okay. So that's what it's going to grow in, per year, right? So this formula now, we want to know, how do we keep it stable? To the question, so I can remember what the question said. Okay. At their present level, which is 25, right? Okay. So I'm going to minus, how many does you have to kill every single year, every single week? Okay, so you've got to minus X, right? Okay. But now, okay, so there's two ways you can do about this. You can say, if, just stay with me for a second. Okay, so P1, do you agree with me? I'll give you a mini break after this. Okay, is equal to 1 plus 1,92. I'll show you what I would do now. I wouldn't go through all of this necessarily. Over 52 times what? If that's P1, what's the one you have again? What's Pn? Pn is P0. Okay, minus X. And so P1 would be equal to P1 would be the same thing as P0, right? You want to keep it at P0. Okay, minus X, right? Okay. So then you could go do this, and you could go, I'm going to show you a quick way now. You could go X is going to be equal to P0. And look what happens if I express it like this. Okay. This thing over here, if I take out P0, that'll be 1 plus 1,922 over 52, right? Okay. And then I'm going to minus P0, right? So minus P0, and I take out P0 as a common factor. You agree with me that's minus 1. Does that make sense? Okay. So X is going to be equal to that. And if we simplify that, basically we get this. And I would have gone straight to this line over here. Okay, in 1 week, how many do you have to kill? Well, the growth rate in 1 week is what? Growth rate in 1 week is 1, the increase, not the amount of pigs. The increase in 1 week is 1,922 over 52. Okay, times however many there were, which is P0, which in this case is 25, right? So I would have gone straight to that. Does that make sense? We've got 25 pigs. Okay, in a week, the percentage increase is, so how much do they increase by? That times by 25, right? So this number over here is how much they increase by. You're starting at 25 in 1 week, that would be the new population. That'll be not the new number of pigs. That'll be how much it's gone up by, right? Okay, so how much it's gone up by must be balanced by how many that the guy kills. Then the population will stay stable. So you could go straight to that if you want. If you want to do this, you can say at equilibrium, P1 will be equal to P0. Okay, and then just solve for X. Basically, if you weren't using this logic, and you just over here, you just put in 25, right? And you go 25 times this, and you get the right answer. Yeah.
Like 3 or 4 pigs.
What do you get now?
Dogs, 1.
Yeah, that's what you should get.
So we did it 1.
Yeah.
Lovely.
Okay, so you should end up with 1 pig per week. You probably didn't change the interest rates. But you understand why you have to change the interest rates. Okay, because it's in per week now. I would, to be honest, in a question like this, I would say to you, okay, what's that? The nominal interest rate per annum compounded. I would break it up a little bit. Okay,
Yeah.
but I would do that what you didn't do. Okay, so you kept it as per annum, but you can't do. If you're killing per week, you can't have a percentage at per annum. Right. You guys in the coma can see. I want everybody just to stand up People at home as well, stand up, and I want you to go walk to the end of that corridor and come back and we go again. It's not a full break, it's a mini break. Okay, go. Okay. To the end. Go.
What?
2 minutes.
Sitting there. I'm gonna finish my cup of makeup. Finish a whole glass. I drink a lot of tea in an air. Got you.
Yeah, 9 cups a day.
Oh, yeah, so I drink a lot. I need hydration, and I guess. No, but there's caffeine, so dehydration. That is good. I was trying to find, I don't know what you call it. An outside, trying to be optimistic. Yeah. Crush that. Although surprisingly, tea always makes me sleepy. It's weird. It is because I have tea every night before I go to bed.
Yeah.
And coffee doesn't work on me either because I break it down too quickly. Oh, but the genetics it's not fun. I hate it. That's my mother's genes. How lovely. Haha. Those your mother's genes? That she breaks on coffee. No, you're funny. I'm so funny. Actually, thank you for so good to do it. I didn't mean it. I was like to show them. No, she tries to do it. I was like, oh, I need to apply for that. Okay, that's so okay.
Then it's not working. It's all one switch. All right, guys at home. Okay, all right. You're gonna go 25 minutes, then have another 2 break.
That's okay, we can.
It's a long day. Okay. Yeah. Okay. Right. So we're on page 7 of your notes. Okay, it says, how many years will it take for the Ghanaian population of 23 million to be double if it is growing at that rate? Well, quite honestly, you don't really want, you could get a recursive formula, but remember the question with money. Any questions on how long does it take to double your money? What did we use? Compound interest formula, right? So you can use X. The amount is actually irrelevant. You could put in 23 million and 46 million, but you could just simply go, well, if that's your compound interest formula, A is equal to P, 1 plus I to the N. In this notation, we could say the population at N is equal to P0, 1 plus R to the N. So we need 46 million and 23 million, but that's quite a lot of work writing down the big numbers. Okay, so whether they had 2 million, compound interest, the amount is to double the amount, irrelevant to what the amount is. It'll take the same amount of time, right? Okay, whether that was 50 Rand or 50 million Rand, the time it takes to double your money would be the same thing. Except obviously with 50 million Rand, you're going to end up with a lot more interest than the guy who had 50 Rand in the same amount of time. Okay, so here I'm just going to say 2x. is equal to X, 1,97%. The time frame is correct. Yeah. Do that for me. Let's see you get the same ones. Why? Because when I divide out, 2 to the X divided by X is just going to be. So if I divide both sides by X, so remember, this is a modeling exam, not an algebra exam, right? So you could just go use the solve button on your calculator if you wanted to at that point. But if you weren't, if this was a core exam, what would you do? Go log base 1 plus 1,97%. Okay. Of 2 is equal to 8. Yeah, time frame, you have to round up. The population, it's in between the two. It's like if you have 3,62, you'd say between 43 and 44. But for something to double, it will be, you have to go, even if it's comma 1, you could round up. Because before that, you wouldn't have doubled it. Does that make sense? So I got an answer of 35,53. Did you solve?
Yes.
Okay, right. Right. And so now, would it take 35 years for this population to double? Even if it's 35,1, it wouldn't take, by 35 years, it wouldn't have doubled, right? Okay. So after 30, it will double every 36 years. What about that? Okay, right. So this we've actually just done this over here. Don't worry about this question, we've actually done already, but let me just show you. As a recursive formula, Malthusan as a recursive is p to the n plus 1 is equal to p to the n 1 plus r. As an explicit, well, you're using a is equal to p1 plus I to the n, so that's recursive. Or a difference equation, just terminology. An explicit or general formula for Malthusian would be p to the n is p0 1 plus r to the n. Okay, that's the explicit form. Same equation. So remember, a difference equation is a recursive formula. Okay. Right, try the next question. This doesn't blind you, you see. Light. Evidence is overwhelming. If a classroom is dark, you have a tendency to drift off more than if it's light. Okay, so speak to your neighbor, try the next one. I'll start doing it too.
Yeah. Yeah, those are this requires a difference equations. So you can put one as the 25.
Take your equations.
You didn't need to say P0. Yes, you do, sorry.
Okay, so I said that the growth rate is birth rate minus death rates. 65%, you just write, you could write 65% instead of 0.65. And you get a growth, an intrinsic growth rate of 0.317. And the formula is going to be 1.317 every year, 35 components. Weasel. Okay. Weasel, Google it, it's like a little parrot kind of thing.
Yeah.
Quite vicious.
Oh, that's big. Oh.
Right, just one thing, okay. Why can I not use an explicit model here? Because of this minus 35. Okay, there is no explicit model for this. Okay. So 19 years, you're just going to use your calculator. You're going to go 120 equals all clear. Then you're going to go answer times 1.317 minus 35. Okay. And so what did you get for P1? I got 123. So you got to work out P90 using your calculator. That's just a question of counting. Okay, right. 1905, I got. Look, ideally, okay, you shouldn't round this off. Fair. You shouldn't. Fair. Ideally, you shouldn't. But what we would normally do is we'd say, assuming R is equal to 0.32, something like that. Okay. Right. So the rounded version, I think I got 1,905. What did you get for the unrounded? 1874.78. Anything, okay, we're not getting too stressed about that. Okay. But generally, as a principle, if we don't tell you, give it decimal places, specifically, you should probably use it to answer button in the calculator. All right, so to double, what number do we have? You can't use the formula, the compound interest formula. So you basically have to say, when do I hit 240? Okay, so you're going to go back to your calculator and go do the same thing again for question C. Back to your calculator. Okay, and you're going to enter once again. Do the step. Okay. Right, so you're going to go put 120 in your calculator, clear the screen, press equals, and then you're going to go answer times 1.317 minus 35. Okay. And you've got to stop when you get to something about 240 and count at the same time. Okay. No. I've got between 9 and 10. Okay, so it's between the 9th and 10th year, right? Actually, but really you should round up. So after 10 years, it will have doubled. You should get on your calculator. The population will never die out. Okay, because if you kept pressing equals, it doesn't, it just,
Then she got to Eric's the number.
yeah. So at the end, actually, the population will grow exponentially. So the answer for D is no. Don't worry about E. Okay. But E, okay. Even though there's a minus 35, that's not enough for equilibrium. If you kept pressing your button on your calculator, go on and on and on, numbers get really large, right?
Yeah.
So even though there's, okay, the number of weasels being killed per year doesn't stop exponential growth. Okay. So the graph would be an exponential growth. Okay. So, the question. Explain why it's not a reasonable. Anything that's got exponential growth is not reasonable because in the end there'll be some problems. Okay. Right. The number of people in the world can't become 65 billion. Okay. Right. Okay. So let me just see something. I'll give you those figures so I can get at it. Okay. Fine. So 10 minutes, another break, a decent break. Okay. Or 12 minutes. But we're actually just going to get your highlighted lots. People at home. Okay. Right. We're on the next page of the notes. People at home, if you've got a problem, just shout out and interrupt. Okay. If anyone's still there. Right. The temptation at home is always too great. Okay. So. Right. So let's have a look at these notes. Okay, and we have done with the Malthusan model. Okay, and this model, okay, there's one aspect of this model which is complicated. My first couple of years of teaching it, and quite honestly, I didn't quite actually get what they were going on about, but I have completely figured it out now. Okay, while we're redoing these notes numerous occasions, right? So now you're lucky you'll go to taught correctly. Okay, so actually I did teach it correctly, but I didn't quite understand why I was teaching it correctly. Okay, right. So the next model, so then there was a problem with this model. Okay, we'll read through it now. Okay, so let's just read. Okay, right. So the flaws of the Malthusan model. Well, you've seen them already. Okay, so first of all, it assumes growth is constant at an intrinsic growth rate. Okay, so the assumption that R remains constant is based on the assumption that death rates and birth rates remain constant, which isn't always the case. And remember that Malthusian trap, or the Malthusian critical point. Okay, the population collapses. Remember, we said does this, goes up, drops down, does this. Okay, right. And this is really the key idea that the population, it assumes population is independent of density. Okay, but the logistic model says not the case. Okay, it says that if you've got a population in a confined space, which is the Earth, even, eventually what happens is as density in population, we're talking about population density increases, then other things start to kick in. Okay, so it says here the growth rate of a population does not remain constant, but it slows down as the population increases. Okay, as the population gets bigger and bigger and bigger in a certain area, okay, for various reasons, it starts to slow down. Okay, the environment naturally restricts the growth of the population. Okay, like in a Kruger Park. Okay, theoretically, there's a certain number of elephants you can have, because eventually there'll be no trees left, right? Okay, and the maximum population an environment can support is called the carrying capacity. K is the symbol we're going to use for that. You'll come across this in life sciences. Okay, of the environment. Have you not done this yet? Population modeling in life sciences? Is it? Okay, well, great. You're going to look clever. Okay, so the carrying capacity of this thing over here is the yes, it's possible. Okay. Okay. So the carrying capacity, I've tried to stop that for years. Never going to go. The problem with the model is exactly that. One of those things is that problem of K. What is the carrying capacity? Okay. So unlike in the Malthusian model, the growth rate slows down and does not always collapse dramatically. So a classic population that's doing in most Western populations are these good models of what is going on with population growth. So what happens is, we'll see it on the next page, what your growth does is this. It increases initially intrinsically because there's no population restrictions. The density of the population isn't high. But as the population gets down, it's on the next page. With time, so now if you've got a graph of population against time, with time, the rate of change or the rate of change slows down. So the growth rate is still positive, but it slows down towards the carrying capacity of K. Plateaus. So as the population increases, competition for food, water, and an increase in the ability for diseases to spread. I mean, the population's on a confined space, diseases spread quickly. Okay, leads to, where were we? Birth rate slowing down and death rate increasing. That's the logistic growth rate. We're going to talk about this parameter now. This is where it's going to get a bit confusing. Okay, logistic growth rate is a different type of growth rate. Okay, it's a function of population. So logistic growth rate of the population decreases. The population growth, the growth rate of population reaches zero when the population reaches the carrying capacity of the environment. And so steady state equilibrium is reached at case. And population growth forms an S shape. That shape is called the sigmoidal curve and has a limit as k. Right, so if you go to the graph, which is more important, I do like test giving you graphs. So this is the graph. Malthusian growth rate does this in red. Okay. Why are they in dots? Okay, because they're discrete data. You don't calculate it's in between a year. This model is to calculate at the end of each year. So with both models, so we're looking at number of individuals, PN, population, against time, which is in N. Okay. So now this, the Malthusian model, we know does this. Okay, it's just exponential growth. Okay, it increases over here. Okay, so there's your Malthusian growth rate in red. What the logistic model says is that things change at this point of it. There's a point when the population becomes dense, stay with me, the population becomes dense, and so your gradient decreases. Population growth rate slows down. And you get a point of inflection on the curve. But we can't use derivatives, by the way, because all of that is assuming continuous start curve. So you get a point of inflection where it changes from concave up to concave down. And it starts flattening out. And eventually, there's a limit. We say that as n tends to infinity, so as time goes on, the population will head towards a constant. In reality, what happens is this. It doesn't really just go like that. It actually, most populations fluctuate around your carrying capacity. So some they go a bit above it, they go a bit below it, but they settle at about that level. So there's slow growth over here. Effectively, there's no growth. This over here is your logistic growth rate curve. So they both start off with a intrinsic model. So your growth rate is constantly slowing down on the logistic model. Right, so now, okay, 5 minutes. Now I get a little bit confused. Well, not too bad. So, a couple of things, a couple of parameters that we're going to work with. You get this thing over here. If you've got a curve, a growth of a we get a parameter R, which is intrinsic growth rate. I don't know if you want to take a little note of this. It's all in your notes, but not in this form. R is your intrinsic growth rate. In any population, how do we figure out R? R was equal to, remember that the increase in the population over the original population. So in population notation, R is equal to P to the N plus 1 minus Pn over Pn. If you manipulate that, by the way, you get R times P to the N plus Pn is equal to P to the N plus 1. All right, which is our formula for intrinsic growth rate. No. Okay, if you want to percentage, yes. Okay, but R is given as this as the ratio. Okay, so that's what the intrinsic. That's how you find intrinsic growth rate, right? Okay, it's a ratio of a population. Now, if I'm talking about the growth rate of a population, okay, what the growth rate is your average gradient between 2 points. But if you have a curve, okay, and say we're looking at that, we've got some points over here, Pn, sorry, this is time n. We're going to call this, so that's n, and we go one time period later, so that'll be n plus 1, the x coordinates, if you've got n against Pn. Okay, then this is the population at n, this is the population at n plus 1. How do I find the average gradient? We just done it in core. How do I find the average gradient between 2 points in the graph? So we're going to do the derivative. What's the average gradient going to do? The gradients of the straight line join those 2 points, right? So what did your average gradient between these 2 points be?
Oh, sorry, Pn plus 1.
Okay,
Minus Pn.
and the growth rate, by the way, we're going to talk about is delta P. Normally delta P means that it's not a rate, okay? But delta P, so your growth rate is going to be equal to change of y, so Pn plus 1 minus Pn over change in x, which is n plus 1 minus n, right? Because the x coordinate here is n plus 1, that's n, right? What's the bottom number become? So it's a bit weird because we talk about this as your growth rates, but it ends up looking just like change of P. But it's still a rate, but it's from 1 year to the next. Okay, so that's going to be your growth, what we call your growth rates. Okay, from 1 year to the next, that's your growth rate. Okay. Right, and then finally, okay, we're going to break now. Okay, you get something called your logistic growth rate. Okay, this growth rate gets referred to in all the models. Okay, but logistic growth rates is also sometimes called your smooth. We don't really use the language, but it helps me to remember something. To understand what's going on. Okay. And I'm going to explain it to you using, okay, so if you have 2 points, this is what a smooth straight line is, okay? Say we have n over here, and you've got m first. This is m, and that's k, right? And you have 2 points over here, right? Somewhere on this curve. Okay, and I want to find the logistic growth rates. Okay, so this is what we do with logistic growth rate. We say, okay, this point over here is k and the population at k. Right? And this point over here is m population of n. And the key really idea, okay, of a logistic growth rate, okay, it's going to be equal to your growth rate. What is growth rate really? It's an average. Did it over here. It's an average gradient, right? Between the 2 points. Okay, so it's going to be your average gradient between those 2 points. Okay. Now over here, it was over the original population, right? Okay. In this case, it's the growth rate. This was the original population in this parameter. Yeah, it's going to be over the population that's in the middle of the 2 points. Okay, but here we divide it by the original population. Okay, this is the hardest part, by the way, of this whole section. Okay, the next model, okay, is actually really good. Okay, over the population, and if you get this right, okay, this is the hard part. Okay, over the population in the middle. So in this particular case, in the middle of, how do I find the midpoint of something? I don't have to divide by 2, right? So do you agree with me? The middle of m and k is m plus k over 2, right? So there'll be another point here, m plus k over 2, and the population of m plus k nearly done over 2. Okay. So to find the growth, the logistic or the smooth growth rate, it basically means an averaged out growth rate. Okay, the average, we're really finding the average growth rate between that point and that point, relative to the points in the middle. Okay, yeah.
Okay. Second point at the one you said green. Up there. Is it PM plus PK?
No, it should be P of m plus k over 2. In other words, the population at m plus k over 2.
Okay.
Sorry, thank you. Okay. So your growth rate, what is the growth rate? It's an average gradient, right? Between the 2 points. Now, what would the average gradient be? Change of y. So this bit over here. The growth rate would be change of y, which is going to be pk minus pm. Right?
Yes.
Divided by change of x, 1 more minute. Okay, divided by change of x, which is going to be what? Between these 2 points. The change of y is pk minus pm. Your change of x is k minus m, right? So that's your average growth rate. Okay. Divided by what? Relative to the point in the middle of that, right? So in other words, population at time m plus k over 2. Okay. So, and I've put 1 second. And that's how we get this over here. Okay. So I'm glad it's something. Otherwise, it's been awkward. Okay. So the symbol we're going to use for logistic growth rate is this. So delta, what confused me was this. That delta P in my head was the change of population. Okay, but it's actually in this note, in this particular section, delta P is a rate, it's your average gradient. Okay, so delta P is an average gradient. In one time period, it does turn out to just be your change in population. But in general, the notation of this section of delta P means the average gradient between 2 points. That's what confused the crap out of me, okay, when I first started to teach this. Okay. And P, it's a function of the population in the middle of those 2 things over there. Okay. And that for me is the hardest part of this section. Okay. And I think you need a proper brain. Okay.
Oh, you did not have
All right, people at home, it's 10:55. Okay. Do we need 15 minutes or 20 minutes? 15. No, not sorry. Okay, so it's now 10:56. People at home, that'll be 10:56 plus 15 makes what? 11. Okay. Can I start replying to this person? I think you need to start showing me these pictures, but you've done these things. Okay. Right. Yes, you need my phone. You can cost me in the staff room. Right, if you want coffee in the staff room, we can go get. You're just going to give me some real horse. Thanks, man. Thanks, man. I don't get it. Okay, I would definitely go to the fund and have a change of scenery.
So cool.
Picture.
Why would you always have it? Oh, no, it's great. This is the funny one. No, I didn't.
And being like your age and dealing with boys that are your age, it's like 2 different species. You're to like over here, boys your age are like absolutely clueless.
Oh, that's funny. For you.
Well, actually, men.
Yeah,
Yeah, but even then, you eventually realize you'll eventually realize that actually they never catch up to you. I mean, there's 2 guys at some point, they're about 60. When they come to the pool together, they're like 2 little boys. So
my brother's 2 years older, but I feel like we're on the same maturity level. Yeah.
probably you're a bit above.
Yeah.
That could grow both.
Let's stop recording. If you're still at home, I'm gonna go out and come back in. Right. Stop recording.